Welcome to aminacademy.com. In fluid mechanics, let us do some example problem regarding thermodynamic properties of a gases. Example, a cylinder 0.6 meter cube in volume contain air at 50 degrees Celsius and 0.3 Newton per mm square absolute pressure. There is the air is compressed to 0.4 meter cube. Find the pressure inside the cylinder assuming isothermal process. Find also the pressure and temperature assuming adiabatic process. Take K equal to 1.4. Here the temperature, initial temperature, that is T1 equal 50 degrees Celsius given plus 273 equal 323 Kelvin. 323 degree Kelvin. Pressure, that is initial pressure P1 equal 0.3 Newton per meter square. 0.3 Newton per mm square, which is equal 0.3 into 10 power 6 Newton per meter square. Now, the final volume, because the gas is compressed up to 0.4 meter cube, that is V2 0.4 meter cube. Now, the compression index, that is K equal 1.4. Now, first let us discuss about isothermal process. ISO, in isothermal process, we have the equation P by rho equal to constant, which means PV equal to constant. Now, from that P equal to constant, you can write P1 V1 equal P2 V2, initial and final condition. Therefore, from that P2 equal P1 V1 over V2. Now we have P1 0.3 10 power 6 V2 equals 0.4 meter cube over V2 equals 0.4 and V1 V1 is 0.6 meter cube. Here first V1 equal 0.6 meter cube. Now let us calculate by using calculator. Here 0.3 into 10 power 6 into 0.6 over 0.4. Here, which is equal 45 4 zeros, Newton per meter square, which is equal to 0.45 Newton per mm square. Now, let us consider the second part, adiabatic process. Adiabatic. In adiabatic process, we have the relation P over rho power K equal to constant. Therefore, we can write P V power K equal to constant. In generally, we can write P1 V1 power K equal P2 V2 power K. Now, here P2 equal P1 V1 power K by V2 power K. Now, which further you can write P1 into V1 by V2 power K. Therefore, P2 equal, here we have P1. P1 is 0.3 in 10 power of 6, 0.3 power of 6 into V1. V1 is V1 is 0.6 and V2 is 0.4. 0.6 over 0.4 power K is 1.4. Further, you can write 0.3 into 10 to the power of 6. Here, 6 by 0.6 over 0.4 is 1.5 power 1.4 equal, here 0.3 into 10 power 6 into 1.5 power 1.4 equal 529235 923556 Newton per meter square. Therefore, P2 equal 0.52923556 Newton per mm square, approximately here 0.53 Newton per mm square. Now, further, find also the pressure and temperature. Now, temperature will find first. We'll find the temperature. Now, we know that PV equal to RT, and also and PV power K equal to constant. First is isothermal, second is adiabatic. Now, from that here P equal RT over P, and And the second things, and instead of P we can write RT over V into V power K. Here first case, therefore R, from that we can say RT into, because V power K by V power 1 equals V power RT into V power K minus 1 equal to constant. Therefore already we have here R is also a constant. Therefore further we can write, T into V power K minus 1 equal to constant, which means because R is already another constant, another constant. From that, therefore we can reach T1 V1 1 power K minus 1 equal T2 V2 power K minus 1. From that we can get T2, that is a final temperature of the gas, equal T1 into V1 by V2 power K minus 1. Now already the initial temperature we have 323, which is equal 323 into V1 by V2 is 1.5 power 1.4 minus 1. Now we'll calculate this. T2 is 323 into 1.5 power 1.4 minus 1 is 0.4 equal 379.87, which is approximately equal 380 Kelvin, which is equal minus 273 107. Therefore final temperature is 107 degree Celsius. Now we got the final temperature in adiabatic process. In isothermal process, there is no change in temperature. So we are finding the final temperature in adiabatic process. We have done. Please subscribe our YouTube channel.